Hi everyone, welcome to our physics class. So this is motion along a straight line, part 14. Okay, well let's start today's class. So in this class, we are going to discuss about the next very important numericals. So this is numerical number 17. A train accelerates from 36 kilometers per hour to 72 kilometer per hour on covering a distance of 50 meter. Calculate the acceleration of the train and the time taken to cover the distance of 50 meter. So read the numerical carefully. So what is given? So that is very important. So actually here the initial speed of the train, initial velocity that is given 36 kilometer per hour. So 36 kilometer means 10 power 3 meter, right? So 1 hour is actually 3600 seconds. So 1 hour is 60 minutes. So 1 minute is 60 seconds. So 60 into 60. So this is 3600 seconds. So that can be written in the form of 36 into 10 power 2, right? So 36 cancels, 10 power 2 that is shifted to the numerator. So what happens? 10 power minus 2, 10 power minus 2 into 10 power plus 3, that is 10 meters per second. So this is the initial velocity of the train. So what is the final velocity? That is 72 kilometer per hour. 72 kilometer is 10 power 3 meter. So divided by 1 hour is 3600 seconds. So that is 36 into 10 power 2 seconds. So that is 6 ones, that is 6 twos. So 2 into 10 power plus 3, 10 power minus 2. 10 power 2 that is shifted to the numerator. What happens? 10 power minus 2 into 10 power 3, that is 10. So 2 into 10, 20 meter per second. So this is the final velocity. And here the distance traveled is given. X is equal to 50 meter. So we have to find out the acceleration, right? And also the time taken to cover the distance of 50 meter. Okay. So acceleration, so that can be calculated by using the third kinematic equation. Because here v naught and x is given, we have to find out a, right? So by using the third kinematic equation, that is v square is equal to v naught square plus 2ax. So 2ax is equal to v square minus v naught square. So a is equal to v square minus v naught square, v square minus v naught square divided by 2x. Okay. So what is the value of V? V is 20, 20 square. 20 into 20, so that is 400. So V naught square, 10 into 10, that is 100. Okay. So divided by 2 into X. 2 into, so what is the value of X? That is 50. So here V square means 20 square, V naught square, that is 10 square, divided by 2 into X is 50. Okay, so 400 minus 100, that is 300, divided by 2 into 50, that is 100. So two zeros get cancels. So finally we will get A is equal to 3 meter per second square. So what is this? Acceleration of the train. So and then we have to calculate the time taken to cover the distance of 50 meter. That is actually the second part. So that can be calculated by using the first kinematic equation, that is V is equal to V naught plus AT. Okay, so AT is V minus V naught. So T is equal to V minus V naught divided by A. So V is 20, V naught is 10 divided by A value, that is 3. 20 minus 10 is 10 divided by 3. So 10 divided by 3 is 3.333. Okay, what is the unit? Second. So acceleration of the train is 3 meter per second square. Acceleration of the train, it is 3 meter per second square, and time taken to cover the distance of 50 meter, that is 3.333 seconds. Okay, the next numerical, a ball is thrown vertically upward and it reaches a height of 90 meter. A ball is thrown vertically upward and it reaches a height of 90 meter. Find the velocity with which it was thrown and the height reached by the ball 7 seconds after it was thrown. And here acceleration due to gravity, that is given 9.8 meter per second square. Okay. So what is given here? The final velocity. What is the final velocity if it reaches a height of 90 meter? So its final velocity is equal to 0. So we have to calculate the velocity with which it was thrown. That means the initial velocity. So if a ball is moving vertically upwards, ball is moving vertically upwards, so acceleration of the ball is minus g, right? That is minus 9.8 meter per second square. And h value is 90 meter. Okay. So first here we have to calculate the initial velocity, that means velocity with which it was thrown. Okay, so by using which kinematic equation? By using the third kinematic equation, because here V naught A H is given. So V A and H is given, we have to find out V naught. So V square is equal to, what is this? So this is the third kinematic equation. V square is equal to V naught square plus 2GH, right? So V square is 0, V naught square minus 2, G is 9.8, H is 90. So V naught square is equal to, so 2 into 9.8 into 90. So what is the value? 2 into 9.8 into 90. So the value is 1,764. Now square root on both sides. So V naught is equal to, so root 1,764, that is 42. This is 42 meter per second. Okay. So this is the first part. So after that, we have to calculate the height reached by the ball 7 seconds after it was thrown. Okay. So the height reached by the ball after 7 seconds. Okay, what is the initial velocity? That is 42 meter per second. So here H dash is height reached by the ball after 7 seconds. Okay. So this can be calculated by using the second kinematic equation, that is x is equal to v naught t plus of a t squared. So here the ball is moving vertically upwards, a becomes minus g, that is minus 9.8 meter per second square. So x is h dash, v naught is 42 into t is 7. Okay, so minus 1 by 2, a is 9.8, t square, 7 square, that is 49. Okay, so 42 into 7, that is 294 minus, so 9.8 into 49. 9.8 into 49, that is 480.2 divided by 2. So that is 240.1. 240.1. So H dash is equal to 294 minus 240.1. So 53.9. 53.9 meter. Okay. So the velocity with which it was thrown is 42 meter per second, and the height reached by the ball 7 seconds after it was thrown, that is 53.9 meter. Right? Okay, so the next numerical. A body is thrown vertically up. The body is thrown vertically up from the top of a building with a velocity of 10 meters per second. It reaches the ground. It reaches the ground in 5 seconds. Find the height of the building and velocity with which the body reaches the ground. A body is thrown vertically up from the top of a building with a velocity of 10 meter per second. It reaches the ground in 5 seconds. Find the height of the building and velocity with which the body reaches the ground. So now look at this diagram carefully. So actually here, a body is thrown vertically up from the top of a building. So this is the top of a building. So let us consider this location as A. So A is here, the initial position of the body. So actually here body is thrown vertically up from the top of a building. So with a velocity of 10 meter per second, actually that is the initial velocity. Okay. The initial velocity, so this is for vertically upward motion. For vertically upward motion, so what is the initial velocity? V naught, that is 10 meter per second, and A becomes minus G. So G value is 10. So minus 10 meter per second square. So the maximum height reached by the ball, let us consider this location as B. Okay. So the velocity at the point B is equal to 0. For vertically upward motion, the initial velocity of the body is 10 meter per second. Acceleration is minus G because it is moving vertically upward under gravity, right? So at the point B, its velocity becomes 0. Okay. So after that, it is moving vertically downward, again under gravity. Let us consider this location as C and this location as D. Okay. First here, we have to calculate. So what is the distance traveled by the body from point A to point B, and what is the time taken by the body to travel from point A to point B by using kinematic equations. So first here, let us consider the third kinematic equation. So for vertically upward motion, V naught is 10 meter per second, that is given. So this is the initial velocity of the body. The body is moving vertically upwards, that is why A is equal to minus G. So at the point B, the final velocity is 0, and the displacement X is equal to AB, right? So here by using the third kinematic equation, that is V square is equal to V naught square plus 2AX. So V square is 0, V naught square is 10 square. Okay, so this is minus 2 into 10 into X is AB, right? So this is shifted to LHS. What happens? So plus 2 into 10, 20 AB, that is equal to 10 square is 100. So AB is equal to 100 by 20. So actually a 0, 0 cancels, to answer to 5 out. So AB is 5 meter. AB is equal to 5 meter. So this is the distance covered by the body if it travel from point A to point B. So what is the time taken by the body to travel from point A to point B? So that can be calculated by using the first kinematic equation. So let us consider here T be the time taken, T be the time taken by the body, time taken by the body to go from where to where? From A to B. So now by using the first kinematic equation, V is equal to V naught plus AT, V is equal to V naught plus AT. So for vertically upward motion, so initial velocity is 10 meter per second. A is equal to minus G, so this is minus 10 meter per second square. And the final velocity V. So if the body reaches the point B, so its velocity becomes 0. So substitute these values in this equation. So V is 0, V naught is 10, so minus 10t. So 10t is equal to 10, right? So t is equal to 10 divided by 10, that is 1. Okay, so t is equal to 1 second. The time taken by the body to go from point A to point B, that is 1 second. The distance covered by the body to go from point A to point B, that is 5 meter. Okay. So actually total time taken by the body to reach the ground, total, that is given, total time taken by the total time taken by the body to reach the ground, that is 5 seconds. Okay, that is how much? 5 seconds. Total time taken by the body to reach the ground is 5 seconds. Time taken by the body to travel from A to B is 1 second. So B to D is 5 minus 1. Is it not? So time taken by the body to go from B to D is, let us consider that is T dash, that is 5 total time minus 1. So this is 4 seconds. Total time taken by the body to go from point A to point D is 5 seconds. Time taken by the body to go from A to B is 1 second. So B to D is 5 minus 1, that is 4 seconds, right? Total time taken by the body to travel from A to D is 5 seconds. A to B is 1 second. B to D is 4 seconds. Okay. Now let us consider for vertically downward motion. For vertically downward motion. So for vertically downward motion, the distance traveled by the body, that is BC plus CD. Let us consider CD. Actually, this is the height of the building. So we have to calculate the height of the building, right? So H be the height of the building. So CD is H. This is H. So BC, that is exactly equal to AB, right? So BC is equal to AB. So AB is 5 meter. So that is why BC, that is also equal to 5 meter, because AB distance, that is equal to BC distance. This is 5 plus h. And what is the time? Time taken by the body to travel from B to D, so that is 4 seconds. So this is the distance covered by the body to go from B to D. Okay, so now by using the second kinematic equation, by using the second kinematic equation, that is x is equal to v naught t plus of a t square. So here body is moving vertically downwards, so a is equal to plus g. This is plus 10 meter per second square. So what is the value of x here? X is 5 plus h, 5 plus h, so v naught t. So for vertically downward motion, what is the initial velocity? At point D, the initial velocity, that is equal to 0. Okay, so this term goes to 0. So of A becomes G, that is 10. So T, time taken by the body to travel from B to D, that is 4 seconds. 4 square is 16. To 1 0 to 5 0. Okay, so 5 plus h, that is 16 into 5. So this is 80. So finally h is equal to 80 minus 5. So this is 75 meter. 75 meter. So the height of the building is 75 meter. What is the height of the building? That is 75 meter. The velocity with which the body reaches the ground. So that is, this is step number 3. Okay. The velocity with which the body reaches the ground. So this can be calculated by using the first kinematic equation, that is V is equal to V naught plus AT. So for vertically downward motion, so what is the initial velocity? For vertically downward motion, the initial velocity is 0 and A becomes plus G. Okay, so this is 10 into time taken by the body to travel from B to D, that is 4 seconds. Okay, so this is 40 meter per second. So V is equal to 40 meter per second. So what is this? The velocity with which the body reaches the ground, that is 40 meter per second. And this is very important for 5 mark. Okay, thank you.